We are looking at December 2022 AFM. This is question number 2, and I would want to go to part B directly. So the following information is provided on the market, risk-free rate, and 2 stocks A and B. So they have given us the treasury bill rate, TB rate, treasury bill rate. This is what we call risk-free rate. And then we have a S&P, which in America is like the Nairobi Stock Exchange. So the S&P index is our market portfolio, is our market security. And then now we have got 2 securities to be evaluated. We have security A and B. So then they want me to do something very simple that everybody was able to do in this sitting. They want me to draw a capital market line. So they want me to draw a capital market line. They want me to draw a capital market line. So is there anybody who can help us draw this capital market line? Is there anybody who can help us, in this case here, draw this capital market line? Is there anybody who could be knowing what the capital market line is known as? Capital market line is also known as who? 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 Somebody has to talk to me. Somebody must talk to me. Somebody must talk to me tonight. Capital market line is also known as the portfolio equation. Yes, is also known as the portfolio equation. Is also known as the portfolio equation. Is also known as the portfolio equation. And if you remember the portfolio equation, this is how the portfolio equation looks like. Anytime they talk of portfolio equation, I always remember the returns formula. I always remember the returns formula. So returns formula, this is quite a simple one. I'm just writing it in a moment. The returns formula. Could be returns of a security or returns of a portfolio. Great. So we have here returns over any security or portfolio equals risk-free plus expected returns of the market minus, in this case here, risk-free. But now remember that the portfolio equation uses standard deviations. The portfolio equation, unlike CAPM, portfolio equation uses what here? Standard deviations. And if you remember, standard deviations, you write it like this and then you pull this. So anytime they talk of portfolio equation, remember I could decide to use P here. P doesn't matter really. So returns over a portfolio must always start from a base, which is risk-free, plus expected returns of the market minus risk-free. So this is the risk premium. When you go to the market to trade in the market securities are quite risky. Look at, for example, securities like Safaricom. Now they are going down. Their value is going down. So market securities, as opposed to risk-free securities, market securities have what we call a risk element. And of course, the moment you go for these market securities, then you should be able to harvest some premium. But this premium has got these risk factors that have to be attached outside there. Risk factors that must be attached outside there. Now listen and listen to me very well. Do we have these 2 metrics? Oh yes, risk-free. Risk-free, ladies and gentlemen, the risk-free rate is provided here. These treasury bills, you can see the treasury bill rate is 4%. So 4%. So we have here 4. So this is 4. Have they given me the expected return of the market? Yes, they did that. They gave me a market index. They gave me a market index in this question, and the market index has been provided here, this S&P, right? The American equivalent of what in Nairobi Stock Exchange, which basically are market of securities and derivatives. So we have in this case here the return of this market securities 11. You can decide to omit the percentages as usual. So then we have here 11, we have 11 minus risk-free, which is 4, multiplied by the standard deviation of any security all over the standard deviation of the market, the standard deviation of the index, the standard deviation of the index given, the standard deviation of the index given, the standard deviation of this index here. You can see it is 15. It is 15. You can see it is 15. Standard deviation here is 15. So abracadabra, if I expand this a little bit, then this RS will be equal to 4 plus 11 minus 4 is 7. Standard deviation of S all over 15. And this is what we call the capital market, what here, line equation. This is what we call the capital market line equation, or the portfolio equation. Remember, it is a straight line. And for straight lines, how many points do we need to be able to define straight lines? How many points do we need to be able to define straight lines? 2. And then what I'll do, if I'm the one doing this, I'll come and ask myself, when standard deviation of the security is 0, when the standard deviation of the security is 0, what will be the return of the market? What will be the return of the security? When this is 0, when this is 0, it will kill the whole term. It means that the return of this security, ladies and gentlemen, in this case here will be what here? Will be 4. Will be 4. So when the standard deviation, remember it is y equals a plus bx. So I'm using the y-axis. I'm using, in this case here, the standard deviation. So this is so important. So important. All right. Now from there, ladies and gentlemen, of course I can see I have some standard deviations given here. Like I can come and ask myself, and I always like working with this. What of this situation when the standard deviation, we have here, the standard deviation here of this security, this standard deviation of this security. What if, for example, I work with 15? So that this and this can cancel. You know, it is just any 2 points. Any 2 points, so long as you get good figures, which don't have too many decimal places, that will give you a problem in terms of plotting them. So if I'm the one doing this, because I can see I've got one standard deviation there, which is 15, I'll come and ask myself here, what if now the standard deviation here is 15? Then returns of our security will be equal to 4 plus 7, but this time around, the standard deviation I've taken it to be 15, all over 15. Can somebody help me? Of course, this and this will cancel out. So giving me what RS? Giving me what RS? Can somebody in this case here? Giving me 11. So 7 plus 4, giving me 11. Now from there, I can go ahead and draw my CML graph. So I can now draw my CML graph using these 2 points that are enough. So the CML graph will look like this. The CML graph will look like this. So we have returns here, remember. We have returns here, remember. We have returns here. And then we have standard what here? Standard deviation here. We have standard deviation. Just a simple graph, very simple graph. So in this simple graph, I know that my first standard deviation here is 0, right? And then I can see the highest standard deviation is what here? Is 15. So I can decide to go 5, 5, 5, 5. So we have here, or a 2, 2, doesn't matter, whichever you choose. Can do here 1, 2, 3, 4, 5, 6, 7, 8. If I'm doing 2, 12 up to 16. All right. Or even 4, 4, 4, it doesn't matter really, or 5, 5 doesn't matter really. It's upon you. So if I do 2, 4, 6, 8, 10, 12, 14, 16, that's very good for me. Now from there, I go to the returns. Returns, I can see here, I have 4, and then I have 11. I can still do 2, 2, 2. So 1, 2, 3, 4, 5, 6. 6 like that. So if I do 2, 4, 6, 8, 10, 12. Like that. So we start with the first point. So when standard deviation is 0, return is 4. When standard deviation is 0 here, return is 4 there. When standard deviation is 0, return is 4. When standard deviation is 15, return is 11. When standard deviation is 15, which is here, I'm told that the return is what in between here? The return is 11. So I'll come and put this there. All right. And then, of course, I only need 2 points to be able to draw this straight line, which I'll be able to connect, which I shall be able to connect nicely. This is my CML. equation like that. This is my CML equation like that. So could you kindly draw something like that? It's not supposed to be a very complicated thing. The moment I appreciate that the CML, how does this equation look like in practice? It's like this, right? Look for risk-free, look for ERM, look for standard deviation of the market. The moment you have them and then you plug them in, then you'll be able to play around till you reach this level. A level of what here? A straight line, a straight line. Great. So is there somebody who has been able to draw this? These are standard deviations versus what here returns. So is there somebody who has been able to draw these? You know, mine is simply to give you like a high level explanation. You guys will be able to watch this video later and draw something better. Draw something better. Great. So the CML, remember there is CML equation and there is KAPEM or security market line. I'll come back to that. Today we are only studying about what here, the CML alone. Now, ladies and gentlemen, once you clear that, then you should be able to go to the next concept here, where they wanted us to calculate the betas of stock A and B. How do we get beta? There are two formulas of getting beta. Is there somebody who can remind us the two formulas? Please don't go to your exams without reminding yourself how to calculate beta, which is a measure of systematic risk. There are two formulas of getting beta. We have the covariance approach, and then we have the correlation approach. Two of them. If you don't understand those two approaches, you'll not be able to score good marks in your portfolio question, which of course I can see ahead of us. You know, as an examiner, all-time examiner now, I'm no longer an examiner nowadays, I know the thoughts of students. Students will always keep on saying that if it came last semester, it can't come again. But you see, just like this is a game. It's like we are doing some football penalty shootout, right? And I will be so happy when I do my penalty push, I do it this way, and then you as a goalkeeper, you jump the other way. That will make me so happy as an examiner. So I'm so sure there must be many students who are saying that this portfolio question cannot be there. And I can guarantee you, it's something that you guys need to appreciate. So I can see so many new messages. So we have got two of them. Thank you so much. Thank you so much. You guys are very clever. You guys are very clever. Actually, I don't even think we should be doing this question. Should we finish this question or should I go to a different question? What do you think? Because it's like you know everything. Should I continue with it or I go to a different question? We are not here to waste time. If it's something that you guys know or we finish, let's then finish it. Let's finish it. Okay. But I saw you guys really appreciate these formulas. I saw you guys appreciating these formulas crazily. But I thought like you're so good at this. Great. Now, ladies and gentlemen, when they talk over BJ, beta J, there are two approaches. If I'm using the covariance approach, this will be covariance between J and M all over the standard deviation of the market squared. All over the standard deviation of the market squared. If I were you, I would have written this very well. And of course, used a highlighter, right? I have to highlight this. This is so important. I have to highlight this. This is so important. This is the covariance approach of getting beta. You take the covariance divided by covariance between the security J and M divided by the standard deviation of the market squared. But if I use now the correlation, if I use the correlation approach, then BJ will be equal to the correlation coefficient between JM multiplied by what here between JM multiplied by what here multiplied by standard deviation of J all over standard deviation of the market. This is very important. This is the covariance approach. This is the covariance approach. This is the covariance approach. Don't go to your exam without knowing the difference between the two models. So then I need now to come and ask myself, really, which method did this examiner want me to use? This examiner wanted me to use correlation approach. That is why he gave us the correlation coefficients. You can see here he's given us the correlation with the market. And because they want for A and B, so I'll come and say beta, I'll come and say beta A, beta A. So beta A, am I able to see the correlation of A? Yes, I can see the correlation of A with the market. It is 0.7. It is 0.7. The correlation of A and the market there is 0.7. Am I able to see the standard deviation of J, which in this particular case is A? The standard deviation of J, I can see it is 25 here. I can see it is 25. I can see it is 25. All over the standard deviation of the market, which we said is our index here, which is 15. Standard deviation of the index is 15. Thank you so much. So could you kindly then give me this answer? Could you kindly give me this answer? What is BA? Beta A. What is beta A? What is beta A? 0.7 times 25 all over 15, all over 15, 0.7 times 25 all over 15. $1.167. 1.167. The examiner has not asked you, but you as a serious scholar, you know that whenever beta of a security is more than 1, then that security is normally given a specific terminology. It's called an aggressive security. Even if the examiner has not asked you, the moment you get beta being more than 1, then automatically you know that this is a security for risk-taking individuals. Security for risk-taking individuals, we normally call it them aggressive security. So this is an aggressive security. If it was 0 point something, then I would have said defensive. So this is aggressive. This is aggressive security. This is aggressive security. So could you kindly try and calculate for me beta B yourself? Try to look for figures to plug in. Please get those figures and plug them in. Because if I plug them in all through, you will think that this Mwalimu is very fast. So beta B, just try yourself. Try yourself, giving me beta B, giving me beta B. You can see the figures there. You can see the figures there. Beta B, give me beta B, beta B, beta B, using this formula. So now we are talking of correlation of B now. Correlation of B. Correlation of B. So the correlation of stock B, I hope you are able to see that breathing space, gives us some time to see these things very well. The correlation of B is 0.4. The correlation of B is 0.4 times which standard deviation? Standard deviation of J, where our J is B now. The standard deviation of B that I'm able to see now, the standard deviation of B that I'm able to see now is 20, is 20. All over standard deviation of the market, which never changes. Standard deviation of the market, which never changes, which never changes, which never changes. So ladies and gentlemen, what are you able to tell me about B? 0.53, and because it's 0 point, so this automatically becomes what here? I'm telling you, ladies and gentlemen, the moment you keep on writing for this examiner, some of these things defensive, some of these things, the examiner automatically will know that they are marking a script of a very bright student. That's how you showcase, you demonstrate broad and a deep understanding of the subject. Deep understanding of the subject. So this examiner wanted us to calculate betas, so which I've been able to do. So the concept that I don't know is whether you guys have mastered how we have done it. How are we comfortable now? Are we comfortable now? Are we comfortable now? Beta, beta, beta. Are we comfortable now? So the moment I see a few yeses there, it means I go to the next level. I go to the next concept. I go to the next concept. Thank you very much. Thank you very much. Now from there, ladies and gentlemen, we go to the next thing where they wanted us to do something very simple that some of my students, as who are marking these things, we realize some people could not even get these things. You know, at times students are also jokers. I don't know that whether they are really jokers or whether they are very busy, because like now, how do you fail to get a question on alpha really, where they want us to give them alpha? I know the formula of alpha of any security. Not unless I'm told otherwise, not unless I'm told otherwise, to get alpha, not unless I'm told otherwise, to get alpha, you write alpha like this. Alpha of a security, you take expected return of a security minus, we basically use CAPM returns. Not unless you don't have those betas. If you have the betas, this is how we get alpha. Alpha is the profitability index. To get the profitability index, you take the expected return of S minus the CAPM returns of S. So then if I'm the one doing this, I'll come and first of all mention the formula of CAPM returns. Is there anybody who can remind us the formula of CAPM? Anybody who can remind us the formula of CAPM? I hope, Sasiet, you have seen your responses from your colleagues there. Anything that's less than 1, if you see 0 point something less than 1, that's defensive. More than 1, it becomes what? Yeah, aggressive. With beta is more than 1, it becomes aggressive. So then who does not remember the formula of CAPM? Thank you so much. You guys are you are gold. You are so special to me. You're able to remember most of these things. But CAPM must always start with risk-free. Must always start with risk-free. Right? Must always start with risk-free. So plus risk premium. The risk premium is like this. Minus risk-free. Come here and multiply this with the beta of the security. So we have 2 securities. We start with A. Are they able to remind us what the risk-free was? The risk-free. Are they able to remember the risk-free from the question? Last semester's question. Are you able to remember? Are you able to remember risk-free? Treasury bills, whenever they use language like government bonds, you know, government, ladies and gentlemen, their things are what you guaranteed. Their things are normally guaranteed. You can never get, even if it's a fake government, if you invest with them, the return is always guaranteed. So yes, I can see the return of this treasury bill. The return of the treasury bill is 4%. I'll omit the percentage. So 4 plus expected returns of the market is what most students were not able to comprehend. The market is this S&P. S&P. So S&P 500 index, just like Nairobi Stock Exchange Index. So it's 11. So 11 minus 4 for security A, I'm able to see the beta. I'm able to see the beta. Are we able to see the beta? Yes. We computed this beta up there. We computed the beta up there. Is there somebody who can remind us what this beta was? Is there anybody who can remind us what the value of beta A we got up there? Beta. I have from Grace 1.167. So times 1.167. Alafu hapa pia usijifanya, body mass is quite a technical thing. Body mass. Be a bit humble here. Go and tell us 4 plus, open brackets, 11 minus 4, close, times 1.167. And you must take this opportunity to practice your body mass. Don't write figures that you are getting, thinking that you have become. No. You must write the figures. You must write them then here. So then they're getting here 12.6, 12.17. Thank you so much. Put it down like that. Put it down like that. Now from there, go ahead and give us CAPM for B. So it will be 4 plus 11 minus 4, because you know the risk-free will not change. The only thing that will change here will be the risk profile, the beta. So is there somebody who can remind us the figure of beta that we got for security B? According to Eugenia, it is 0.5333 like that. 0.533 like that, whatever. So then are you able to give us the CAPM returns of B? CAPM returns of B. Is there anybody who is able to remind us what the CAPM returns of B? CAPM returns of B. So it is 7.73. Thank you so much. We are not yet there. 7.73. 7.73. 7.73. Just underline that. Now, after that, now you can go and close the loop, do the last step. So now you give us the last step, give us the last step. So the last step is the alpha concept. So the alpha concept, so alpha of A will be expected return of A minus CAPM of A, So expected return of A. Can somebody give me the value of expected return of A? You have that past paper. Are you able to see the expected return of A? Are you able to see the expected return of A? They're not talking to me now. They're not talking to me now. expected return of A, I'm being told it's 14. So 14 minus KASNEB returns of A, which is 12.17, 12.17, 12.17, 12.17, 12.17. So where did I get the expected return of A? Expected return of A, you can see it is here. Expected return of A, security A is 14. So 14 minus the KASNEB return, So from Irene, KASNEB of A is wrong. Let's go slowly. KASNEB of A, according to Chonjeri, KASNEB of A is wrong. Let's go slowly. We go slowly here. KASNEB of A. This 12.17 according to Rachel is not right. So please, Rachel, take your calculator slowly, please. Don't open brackets anywhere. Just say 4 plus, open brackets 11, minus 4, you close. Don't say equals. Don't say equals. You continue with times 1.167. Then you say equals at the end of the day. Rachel, I'm waiting for you. I'm waiting for you. You'll see that answer is correct. Most of them cannot be wrong. Not easy. It's called democracy. Wengi wape. Rachel is getting 15.69. 15.69. Rachel, hebu tufanye namna hii Tufanye namna hii Rachel Wachana na hii 4 kwanza. Wachana hiyo 4 kwanza. Hebu sema 11 minus 4. So 11 minus 4 is 7, Rachel. So take 7 times 1.167. Take 7 times 1.167. After you get that figure, then you add it to 4. You add that figure to 4. Rachel, chukua 11 minus 4, body mass, nasema brackets first. So 11 minus 4, utapata 7. Ukisema 7 times 1.167. Whatever you get, unakuja unasema plus 4. Me, I know the mistake that so many guys do. I know the mistake that so many guys do. This is what many students will do. Let me tell you something. And they're not the only ones. It's not Sue and Rachel alone. What students will do because of body mass issues, they'll come and tell you 4 plus 7. 4 plus 7 is 11 times. Can somebody give me this figure? What is 11 times 1.167? Can somebody give me this figure? We'll come that way. Let's see. 4 plus 7. Can somebody try this figure? 11 times 1.167. What figure are we getting, somebody? Or you used 1.67, eh? Oh, so it's not about body mass. It's not about body mass. It's not about body mass. Okay, then I understand. Okay, it's not about body mass. These guys don't have an issue with body mass. But so many students will have a problem with body mass. So ladies and gentlemen, please ensure whenever you're using your calculator, if you don't want to see birds of Mestangede, say 4 plus open bracket 11 minus 4. Don't say equals times 1.167. So this figure is correct. Thank you so much. So then could you kindly give me this figure? I saw some students saying it's 1.83. I saw some students saying it's 1.83. Thank you very much. I can see Umi saying, so if you see this 1.83, it's positive. It's a profitable security. So if it's a profitable security, which name should we give it? If it's a profitable security, which name should we give it? Just to demonstrate that we understand, to scare the examiner. Remember, we thrive through scaring people. We thrive through scaring people. If it's profitable, 2 particular names are very important. What I'll do there, I'll go ahead and call it super efficient. Super efficient. This is so nice that A is super efficient. A is super efficient. And if it's super efficient, then it's also known as what here? Somebody undervalued. A security which is undervalued, just like your motor vehicle, if you want to sell it like tomorrow, just go and undervalue it. It's a Toyota Fielder, which is worth about 1.5. You put it there, for example, you will be surprised. If it's undervalued, even yourself, when you want to make profits, just go and buy things of people who are in financial distress because they are selling them at forced value, forced market rate. So they sell at a lower, so it's undervalued, and that is why it is profitable. Undervalued, and that's why it is profitable. So go ahead and do the same for security B. So security B, what do we have? So for security B, we have expected return of B. Expected return of B. Expected return of B. So expected return of B, it's here 9. It's 9 minus the KASNEB return of B, 7.73. So could you kindly give me this figure? 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 Very fast, please. We are out of time. 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 So they're giving me a figure of 1.2 something, 1.27. And remember, in this particular case, ladies and gentlemen, it is what here again, super efficient because it's profitable. It's profitable. It's profitable. So then the last question, if you allow me for today, they wanted me to plot stocks A and B relative now to the CML. Forget the CAPM. So in this case here, they want me to draw A and B in the CML. This is very easy. What I'm going to do is to locate this 14 and 9. 14 and 9. So let's look for this stock A. You see stock A is 14 with a standard deviation of what here? 25. Stock B, 9 with 20. So no problem. So then what I'll do, I'll come, unfortunately, I don't know whether this will be enough. So we have 18, 20, 22, 24. Great. I've been able to fix it. 26, so I'm Mr. Fix It. But I have to adjust my camera a little bit for the standard deviation to go all the way to 26. And then for the returns, I'll be able to see. So we start with, I'm just plotting A exactly the way it is in the CML. So for A, it is 14 versus 25. Do I have returns of 14 here? Let me see. Do I have 14? Oh, yes. 12. No. I'll have to add 14. So 14 versus 25. 14 versus 25. So I have to extend my CML a little bit like that. So then I have my A being there. I don't know whether I've exaggerated, but the ones who have got good graphs, are you getting your A big below the CML or above the CML? The ones who have drawn this in, for example, a mathematical book, your point A, is it above or below or below? Lily says above, below. Annie says above. Somebody who has got some graphical paper, they're saying above, below. below is becoming quite below. Thank you so much. Then how about B? Can you kindly again try to look for B? Try to look for B. So B is 9 versus 20. 9 versus 20. 9, return is 9. The standard deviation is 20. So return is 9 here. And then the standard, this one I'm able to see it's below. 20 is here. This one, I could debate. B, below. So in the comment, then what do we comment? That both are below the CML. Both are below the CML. A and B are below the CML, which in this case here shows what your poor performance, which shows poor performance. Basically, poor performance equals negative alpha value using the CML. If you use the CML approach, the alpha values would have been what here? Negative. So negative alpha value. So poor performance. So basically, these ones here are overpriced. But the most important thing is that they are below. If you take, like, for example, the expected minus the CML, you'll get negative. Whenever they are below, it means what here? Poor performance. So ladies and gentlemen, now we have come. We have enjoyed, pardon, okay. Just try drawing. You see, this is the CML. The CML is there. And the A and B ziko below. Any chini, ziko chini ya CML. Ziko chini ya CML. Ziko chini ya CML, it means what here? Poor performance. When it's below. Have you tried in this case you're drawing your CML? Have you tried drawing your CML? Patrick. Yeah, if you've drawn your CML, then you'll be able to understand. And maybe, perhaps your A is up. If A was up here in the heavens, then you would have said what? Yeah, good performance. When the point is below, then automatically you say what here? That this particular security is underperforming. Is underperforming. So all of us, have we been able to draw? Hata kizungu tu mingi. Ile kitu iko hapa, so unaona mali hapa A na B ziko chini ya CML. CML iko juu. A na B zina fall chini. These are loss region. Loss region is a loss region. Is a poor performance region. So if A and B are there, unasema they have performed what here? They have performed poorly. Can't be up, used a square rule book. Great. SML, yes, it has a graph, yes. Maybe next time I should be able to do a graph for the SML. Great. So if we call it a great session or a good night, is there a problem? Because I'm so sure most of you, again, have other classes